Good morning, students. So, today I'm going to take a class on a new paper, Introduction to Software Engineering. And in this paper, this is my first class. So, in this class, I'm going to cover the basic concept of software engineering and why we need software engineering. What is the in computer science? So, first we go here. Software crisis means what is software? We know software is a set of programs with proper documentations, and it is consists of lots of programs which documentations and procedures. So software crisis means it was in late 1960s many software projects failed. So many software projects led over budget, providing unreliable software which is expensive to maintain. And many software projects produce software which did not satisfy the requirement of the customer. So complexity of software projects increased as hardware capability increased. So larger software systems is more difficult and expensive to maintain. So demand of new software increased faster than ability to generate new softwares. All the above attributes of what was called software crisis. So the term software engineering was introduced at a conference in late 1960s to discuss the software crisis. So now, why software engineering? Why software engineering needed us? So once the need of software engineering was identified and software engineering recognized as a discipline, so the late 1970s, we saw the widespread evaluations of software engineering principles. The 1980s saw the automations of software engineering and growth of case computer-aided software engineering. And in 1990s have seen increased emphasis on management aspect of projects and the use of standard quality and process model like ISO 9001 and the software engineering institute software capabilities maturity models, etc. This model help organizations put their software development and management process in place. Now, what is software engineering? So different computer scientists define software engineering in different ways. In 1969, Fritz Bauer defined software engineering as the establishment and use of sound engineering principle in order to obtain economically software that which is reliable and work efficiently on real machines. Secondly, according to Boehm, software engineering involves the practical applications of scientific knowledge to the design and constructions of computer programs and the associated documentation required developing, operating and maintaining them. The standard organization IEEE in its standard 610.12 1990 defines software engineering as the application of systematic, disciplined, quantifiable approach to the development, operations, and maintenance of software, which is the applications of engineering to software. So by combining all the above definitions, we can define software engineering as software engineering is the technological and managerial discipline concerned with systematic productions and maintenance of software products which are developed and modified on time and within cost estimations. Major Major goal of software engineering. What is the primary goal of software engineering? So the primary goal of software engineering are to improve the quality of software product, to increase the productivity, and to give job satisfaction to the software engineers. So two main goals we have in software engineering. So foundation of software engineering. So what basic essential building blocks of software engineering? So software engineering is a technological discipline distinct from but based on the foundation of following disciplines. So number one, computer science. Number two, management science. Number two, economics. Number four, system engineering, and finally, communication skills. So how software engineering is related with other discipline? That means the relations between of software engineering with other discipline. So number one, computer science. So computer science gives the scientific foundation to the software as electrical engineering relies on physics. Number two, management science provides the foundation of software project management. Since software engineering is a labor-intensive activity, it requires both technical and managerial control. Number three, economics provides the foundation for resource estimations and cost control. Since computer system must be developed and maintained on time and within cost estimates, thus economics plays an important role. Number four, system engineering, which is the field concerned with studying complex system. Software is often a component of much larger system. For example, the software is in a factory monitoring system or flight software on an airplane is just the component of more complex system. So system engineering techniques can be applied to study such system. Finally, good oral, written, and interpersonal communication skills are crucial for the software engineers because software engineering activities occurs within an organizational context and high degree of communications is required among customer managers, software engineers, hardware engineers, and other technical workers. So difference of software engineering with traditional engineering. So how software engineering is different from traditional engineering? So number one, software is intangible. That means it has no mass, no volume, no color, no odor, no physical properties. Source code is merely a static image of computer program, and while the effects produced by programs are often observable, the program itself not. Number 2, software does not degrade with time as hardware does. So software failures are caused by design and implementation error, not by degradation over time. Number 3, there is always an obscurity in the interface between software modules. So it is difficult to design a software system so that all the control and interfaces among modules are explicit, and so that the modules don't interact to produce the unexpected side effects when they inflict on another. So in classical engineering discipline, the engineer is equipped with tools and mathematical maturity to specify the properties of the product separately from those of design. The typical software engineering relies much more on experience and judgment rather than mathematical formula. While experience and judgment are necessary, formal analysis are also essential in practice of engineering. Now, the role of software engineer. So when we deal with software engineering, then the role of software engineer is important. The evaluation of software engineering field has defined the role of software engineer. A software engineer should have following qualities. Number 1, he or she should be a good programmer, be well versed on data structure and algorithms, and be fluent in one or more programming languages. Number 2, he or she should be familiar with several design approaches, be able to translate vague requirements and desires into precise specifications, and be able to converse with the use of system in terms of applications. Number 3, he or she needs the ability to move among several levels of abstractions at different stages of the projects, from the specific applications, procedures, and requirements to abstraction for software systems, to specific design for the system, and finally to the detailed coding level. Now, what is well-engineered software? So, if the software system does what the user wants and can be made to continue to do what user or customer wants, it is well-engineered. So, any well-engineered software system should have following attributes. Number 1, it should be easy to maintain. Number 2, it should be reliable. Number 3, it should be efficient. Number 4, it should provide an appropriate user interface. So all these 4 attributes are important for well-engineered software system. The development of software must make trade-off between these attributes. Now, distribution of software efforts. So, the typical lifespan for a typical software product is 1 to 3 years in development and 5 to 15 years in use. The distribution of effort between development and maintenance has been variously reported, depending on the type of software, as 40, 60, 30, 70, and 10, 90. So maintenance. Number 1, corrective. Even with the best qualities of software, it is likely that customers should uncover defects in software. So corrective maintenance sends the software to correct the defects. Number 2, adaptive. Over time, the original environment for which the software was developed makes sense. So adaptive maintenance results in modifications to the software to accommodate the sense to its environment. Number 3, perfective. As the software is used, the customer or user will recognize additional function that will provide benefits. Perfective maintenance extends the software beyond its original functional requirements. So, the software product. What do you mean by software product? The objective of software engineering is to produce software products. So, computer software is the product that software engineer design and build. So software products are software systems delivered to the customer with the documentations which describe how to install and use the system. So software products fall into both categories by both classes. Number 1, generic product. Number 2, customized product. So generic product means these are stand-alone systems which are produced by a software development organizations or firms and sold on the open market to any customer who is able to buy them. And customized product, these are systems which are commissioned by a particular customer. The software is developed specially for the customer by some developers. Until the 1980s, the first majority of software systems which were sold that were customized and specially designed systems which run on large computers. They are expensive because all the development cost had to be made by a single client. After the development of PCs, this situation has completely changed. The PC market is totally dominated by software products produced by companies such as Microsoft. This accounts for the vast majority of software sales. These are usually relative chips because their development cost is spread across hundreds or thousands of different customers. So students, today I stop here. So I will come in the next class some new concept of software engineering. Okay, thank you.